want us to with the remaining 45 minutes is more than enough for me to clarify you on what is expected from you on that assignment. Uh, as I was explaining about the outlier, Mr. Chabala told you that it's possible that you can have an outlier in a data set, but you find that the outlier is there, but is it influential? You know the method that can be used to check if an outlier is influential or not. And then if it is influential, if you are having that right to run the data for yourself, it means you have to remove the outlier yourself and do what? And run the results again without that outlier and check if you are still having other influential observations. Remember the issue of an outlier. An outlier is not always problematic. An outlier is problematic if it's creating problems. So we have outliers and we have influential outliers or influential observations. So please understand the definition of an outlier. Not all outliers are influential. So you may have an outlier, but you find that that outlier is not influential. What is the issue with the outlier? The outlier can create a lot of problems in your data set. It can give you wrong predictions. You may find that when testing for this information is there even from the document that I'm saying go and study them. I think document which talks about multicollinearity, it covers some of these things. An outlier, you may find that when you run you feed the model, you expect your beta to be positive. Sometimes some of the things they need common sense. You expect your beta to be negative, but when you run the result, you find your beta being positive. And when you check, you find that you have an outlier. But if you remove that outlier and then you run the result again, you find the result which now makes sense. So there are a lot of issues with the outliers. But for the upcoming assignment, what we will do, we will run the results for you. We'll run the results for you. Maybe we'll run 5 data sets. We'll give you the what? We'll give you the the what? The statement that if you want to interpret this statement, this data set, here is the statement. Like what is y, how y is measured, how the x values are measured, so that you'll be able to bring in what, whenever you're interpreting your result, you must relate to what, to the given statement. So what we're going to do, we'll run maybe 5 data sets, 5 different data sets using the 3 methods: backward elimination method, forward elimination method, stepwise elimination method. So you choose one. So if we run 5 data sets, so it means we'll have how many options? 3, 6, 9, 12, 15. If we're able to run 5 data sets, it means you'll have how many options? You'll have 15 options to choose from. You choose one. If you want to interpret the results from stepwise elimination method, you will choose that. If you want to, let's say I run results, let me just project a whiteboard. Let's say I run results, just want to make it practical so that I run the results now. Data set 1, data set 1. I run using backward elimination method, backward, forward, and stepwise. Suppose this is what is happening. I have this data set named data set 1. I run the results using backward elimination method, forward elimination method, stepwise elimination method. It doesn't mean that when you interpret the results, you must, because these results are from data set 1, you must interpret this one and this one and this one. No, you choose one. If you want results, you prefer interpreting results from backward. It means from data set one, your group will do what? Will do backward elimination method. Another group can decide to do what? From the same data set, they can decide to do what? Forward elimination method. Another group can decide to do what? Backward elimination method. But please, plagiarism is not allowed. If we find that group A's work is the same as another group, you are disqualified. So please, even if you have a friend but you don't belong to a same group, please don't give your friend the work of the what? Don't exchange the what? The work. Because if we notice that, it means you be the group, the two groups will be disqualified. We are not trained to be judges or to go to court. We call you to say who copied what. No, 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 no. You must be careful whenever you are doing these things. So if someone from your group decides to share your work with someone, we won't be I don't think we'll be involved in groups politics. If you share the work, we notice that, we disqualify. There won't be any meetings calling you guys, say who copied the work and sort of. No, no, no. We agreed that you must form groups from the beginning of the semester. So assume those groups are there. And we said the group should be the maximum of 15 members. Maximum of 15 members. So this assignment, I said it should be, and this assignment you have to type it. You have to type the assignment. Um, uh, and then ask one of your members, select a member who will be submitting to us. You can from a group, and make sure that the person, whenever is submitting the work to me, he CC you guys. Because this thing of saying our group leader, he said they will submit, we don't know why he didn't submit. If it's after time, the agreed time, you fail to do that within the agreed time, it means you won't mark it. So please, let's help one another here. So select a member who will help you to do what? To submit the work. Doesn't mean that because we are 15, all the 15 members, they should submit the work. No, only one person should what? Should submit the work. And the assignment should be typed, submitted via email. My email and Chabala's email. Make sure that when you submit to the two of us. So why am I saying this? You may find that you don't know how to write my surname, but you know how to write Chabala's surname. Even if I fail to receive it, maybe you missed my surname, my email address, but you may find that you managed to get the one for Mr. Chabala right. So whenever you submit the assignment, submit the two of us. So can you please allow me to go to the practical part now? I want to show you how to run the results and what should be interpreted. Some of the things that are necessary to be interpreted. Do you allow me to do that? Or you have a question, please ask. If you have a question, please ask. Otherwise, can you please allow me to go and do one problem and explain how to use this thing? Any question, please? Guys, are you still here? Yes, yes.
Yes, sir.
So, leadership, Christopher, all has been saying you promised us that we'll do practicals, but no, we don't know what's happening. So next week, for our syllabus, we're only left with one part, which is which is what is that part? Which is nested models. We have to do nested models. This is the only thing left, nested models. And again, we have lack of fit under multiple linear regression. we have the test of the Ben-Weinstein under what? Under multiple linear regression. So the only thing that you need to know that you have to do maybe in the form of calculations is the nested models. But the Ben-Weinstein test, the procedure is the same as simple linear regression, because you need what? For you to deal with the Ben-Weinstein test, you need the errors, isn't it? So even that part also applies to what? To multiple linear regression. Even the lack of fit. But when coming to the lack of fit, I won't ask you to do it manual. I can give you an output which is having a lack of fit. You must know what you are testing. But even here, when I run the results, even the assignment that you'll be doing, there will be a part where I can ask you to do what? To check if we're not having a lack of fit in our data set. So can you please allow me to just share this slide now, this window. So I will do the class example. For that one, you know our findings. The class example, which is talking about the price, the size, and the age of the house. I want to explain that. I want to run the results. I explain some of the things that are necessary to be what? To be interpreted. So whenever you are asked to interpret results, please, I repeat, please do not use the T tabulated, the T calculated. The question will be saying, interpret the given output. So we won't expect you to be using the T. Whenever you're interpreting an output, use what? Use the p-value. We agreed about that one. That whenever you're interpreting an output, you must use what? The p-value. Don't go to the table, the T table, and start saying T calculated is greater than the T tabulated. Is the T tabulated part of the output? No. You see, you'll be losing marks for things which are not even necessary. So whenever you're asked to interpret an output, use the given what? The given information. You don't have to go to look for tables to interpret an output, but you will see it with this output now here. Let me share the window. Wherever you don't understand, please, guys, ask. Can you see the SAS window? Can you see the SAS window, guys?
Yes, sir.
Not yet.
Yeah.
Now we see it.
Yes.
Yes. Let's communicate, because now whatever I'm going to run here is something that we have covered. It's either with me or with Mr. Chabala. Let me just show you some of the things that can input. Number is the first one. The second one is size. The last column is the price. You know this data set. So let me call it data set, data, class. Let me call it class example. And then don't worry. So next week we'll have a session now where we'll be doing the practicals. Not for the sake of, you have to know these things before you do it. Before you complete your degree, you must know how to use these packages before you complete the degree. And also for the sake of what? Sake of exam. So next week we'll be doing practicals, not under pressure. So Thursday afternoon class and Friday tutorials. We'll use those 2 days to do the practicals. So we have this data set, the class data set. So we know the results that from this data set, we know that price is not related to age, but the price is related to size. We know we have the, why am I saying this? We have the result. So um, um, so I will explain each and every step. equal to data equal to class example. So with this first step, the first statement, I'm simply saying, can SAS give me a procedure? That proc represent what? The procedure. Can SAS give me a procedure to run a regression model for the data set called what? Class E. Why am I saying class E? I called my data set what? Oh, sorry. So SAS, the good thing about SAS is not case sensitive. It's not case sensitive. Even if I use small letter E here, and then down there I use capital letter E, it won't have any issues with that. So the good thing about SAS is not case sensitive. So now the next step I will say my model will have Y. In this case, I didn't use Y. It says what will be a dependent variable. My dependent variable will be is price. So you start with the price. The order matters, ne? Price. So it will go and pick up the price there, equal to size and age. So the system will know that as long as I indicated that my dependent variable is price and the size and age is what? Is my independent variable, because the after what? The after the code, after the equality sign. This is the equation, isn't it? So if you want to get even more things like if you also need what? The confidence intervals for the betas, you can indicate that please, from my output, also give me the confidence intervals for the betas. The system will do that for you. Again, if you want the system also to give you the what? The VIF, the system will give you that. If you want the system again to give you what? The tolerance values, the system can give you that. So whatever you want the system to give you, the system will do that, as long as you have indicated. So assuming that this is the only things that we need. So the good thing about SAS, as long as you run the model, it will also give you the residuals. Whenever you run the model, it will also give you the residual plot. So let's run this one. If you can check, we didn't indicate which method to use, like forward elimination method, backward. We just said, just give us results related to the enter method. So I have to, what I'm doing, there is what I've just done now, I highlighted the data set until the where you see a semicolon there, and I press, you see this, there's a guy running here. What am I doing? I'm simply storing the data set. The data set need to be stored. It needs to be stored in the system, so that whenever you run the results, the data set is there. So if you decide to change a value again here, you must store the data set again, so that the system can see that the data set was what is updated. So when we run this, let's run this. The results are coming. Just taking time. I don't know why. Yeah, the results. Can you see the results part? Can you see the results part, guys?
We can see, sir.
Yeah. So now,
Yes.
you know the background. You know the background of this question is the class example. So if we have been calculating, you don't know what if your answers were right or wrong. Here is what. Here's the platform way which you can use to what, to run the results again and check. Use the system to check. So this is how you are supposed to answer the assignment. You cannot start by saying we're having 20 observations, ANOVA table, we're testing for the overall model. No, you need to follow a certain, we need logic here. There is a flow chart that Mr. Chavala shared with you. You still remember that flow chart? Uh,
Chapter 1.
yeah, you still remember that flow chart?
Yeah.
We need, now you need that flow chart. That flow chart is the one that you're supposed to. Let me share the flow chart for those who don't know. I will come back to this one. Let me share the flow chart so that you can, what am I talking about? Now, remember this flow chart. You remember this flow chart. So whenever you interpret the results, you'll be guided by this flow chart. You see, we said we have this. If we are from the output, we are given the scatter plot between y and x, not the residual plot, the scatter plot, where you check for the relationship. If you see it from the results, copy those plots, make sure that they'll be the first ones to be interpreted. After that, you feed the model. You feed the model. You look for a section which is having what, the model. You copy the model down. You interpret the betas related to what, to the given problem. After doing that, now you can move to the what? You can move to the hypothesis. You test for the hypothesis. What is the logic of testing for the hypothesis? You start with the overall model. When you reject from the overall model, is then now you can move to what? You can move to um, you can move to uh, where now you apply the t-test or the partial f-test. It will depend what is on the data set, on the output. So follow this thing whenever you're interpreting an output. Don't say because from my output, the first thing that is there is the ANOVA table. So I will start interpreting what? I'll start interpreting the ANOVA table because it's the first thing. Except that when you interpret an output, introduce us, guys. You know, you are given a statement like someone want to buy a house, but when you want to buy a house, you want to know the size of that house and how old is that house, and then what type of regression problem are you dealing with. If you are dealing with a multiple linear regression problem, indicate that just introduce us to what you are expecting from your results. You have to indicate that I'm given a multiple linear regression problem where my y is measured this way, and then I have 5 independent variables. How many, if we have categorical variables, indicate them that from my data set, I have 3 categorical variables and 2 numerical variables. If the categorical indicate that they are, if the categorical indicate that these categorical variables are defined this way. Remember the one from the test. I think there's a one where I said indicate what? Define the what? The dummy variables. If that defined for you, indicate that my dummy variables are defined. Whenever I see 1, this is what is happening. Whenever I see 0, this is what is happening. You are introducing us before you can even interpret the results. Introduce us. A paragraph is enough to explain what is happening from your data set. There are marks for that. There are marks for doing that. Indicate that how many observations are you having? How many? What is your sample size? Indicate that. It's here. Like for example, you indicate that I'm dealing with a multiple linear regression problem where my y is the selling price of the house. I want to predict the selling price of the house using the size and the age. The sum, my 2 independent variables are what? A category are numerical, where size is measured this way and where age is measured this way. It will also help you when you get to what? When you get to the interpretation of the betas. It will help you because now you know what is you are dealing with. From there, you can indicate that now you go back to that scatter plot. You indicate that I'm having this scatter plot with which shows that there is no relationship between age and the selling price of the house according to the scatter plot. And then when you go to the size and the price, you say no, but no, but between the size and the price, it looks like there's a positive relationship between uh, y and what, the selling price and the size. You're talking about the scatter plot now. You cannot tell how is the strength of the relationship. You just say it's a visual inspection, isn't it? From there now, you look for a table which can give you what? Which can give you the betas. Here it is. Can you see it, guys? In this case, it's written parameter estimate. Parameter estimate, this is the column that can help you to give, this is the column that can help you to give what? The model. Write the model down. Write the model down the right way. You know how to write the model down. Write the model down, interpret the betas, interpret the betas. So far, if you check from this parameter estimate, I'm telling you that um, for now we only need what? We only need the betas. It doesn't mean that we don't need the other information. For now, we need what? We need the betas. We indicate that okay, our betas there uh, is the model there is 10.04 plus 12.83 size minus 0.056 age. You interpret them. So far from this table, you only took what? You only used what? The parameters. Now you go back to your flow chart. After interpreting the what? After interpreting the what? The betas, what is the next step? Let me test for the overall model. You see, now you are moving away from now you are moving away from you are moving out from this table, the one return parameter estimates. You are moving away from this, but you are not done with what? You are not done with this table. But you know that after writing the model, the next thing that we can do is to what? Is to test for the overall model. What do you use to test for the overall model? Use the ANOVA table. Write the necessary step. Write H0, write H1, um, what? Write them the correct way. This is a group work. So we don't expect you guys to write as if you are writing alone. This is a group work. Make sure that you don't make silly mistakes. And you test. You test alpha. Alpha, if it's not specified from the output, you know it's 5%. But if from the output, you must check the whole output. What is the alpha that was used to run those results? It's your responsibility. When you're given output, it's your responsibility to check which alpha was used to what? To run the results. If not specified, use 5%. I repeat, if not specified, use 5%. Otherwise, it's your responsibility to check what is your alpha from the given output. So now you'll be interpreting the overall model. You know to do that, you need what? You need the ANOVA table. You do the ANOVA table. Again, after considering the ANOVA table, you test. What else can you want to know? You can maybe want to check the variation of y that can be explained by the two independent variables. You know to do that, you need what? You need the adjusted, you need what? R squared, isn't it? Here it is. You are not calculating anything. You are being told to interpret the given output. You interpret this one. Again, the root MSE, Mr. Chawala taught you what is the meaning of the what? Root MSE. I hope you know what is the square root of MSE. You interpret this value. You interpret this value, the square root of MSE, which is what? What is the square root of MSE? What is the square root of MSE, guys?
Standard error.
It's a standard error, isn't it? You have what? I'm just showing some of the things that are important to be interpreted. The dependent mean. What is this dependent mean? Is the mean for y, isn't it? Dependent mean. I cannot tell you how to interpret the dependent mean. You must know by now. And then now you have done that. From there, what? Now after testing for the overall model, using what? Using the p-value. Here it is. That is the p-value. You compare that p-value with alpha, and then you make what? Necessary decision. After doing that, if you have rejected that, some of the um, um, There is a relationship between y and at least one of the independent variables. Now, what is the next step? You want to know which are those independent variables. Where can you get that information? Now it will take you back to what? It will take you back to the parameter estimates table. You can test for that using what? Using the p-values. Using the p-values, or using the confidence intervals for the betas. Provided, I repeat, provided the alpha used for ANOVA table, it was 5%. And if the alpha used to remove the variables using the p-value approach is 5%, you can use the confidence interval again to remove the variables. But let's say the alpha used for the ANOVA table was 10%. 10%, which is what? It's 0.1, isn't it? It means even when you are removing, you use 0.1. But can you use this confidence interval? Let me repeat. Assuming that alpha to remove, it was 0.1, it means even when you are removing using the p-value, you will compare these p-values with what? 0.1. Is it possible for us to use this confidence interval?
No,
Why?
because the alpha is not the same.
Because the alpha is not the same. So we can only use this confidence interval provided here is written what? Assuming we use the alpha of 0.1, this is supposed to be what percent?
90.
90. If
90.
you move with 0.1, if you move with 0.1, so it means the confidence, if you want to use the confidence interval also to remove, you'll use what? You'll use 90%. You must be specific. So you must tell the system that alpha to remove, alpha to be used is this much. This is a group assignment when you are doing the thing, but with us, remember, we're going to run the results for you. That's what I'm saying. Be careful whenever you're checking your results. What was the alpha used to run or to remove? If not specified, please, you can use 5%. Or if not specified, you want to move with this 95% confidence interval. It means if I run the results here, I use 90. It means it can guide you that for me to also use the confidence interval limits, it means I can use, if yes, written 90, it means you can decide. So for our group, we want to use 0.1 as our alpha. Again, you can see now the other, see, I didn't say anything about the standard errors. Why? Because I don't need them when interpreting the results for now. Did I use the t value calculated? No, because if I use the t calculated, it will force me to go to the what? To look for the t tabulated values. But because I don't need it, I don't even have to bother interpreting what? Interpret using these values, because immediately you want to use these values, you will need what? You will need the values from the table. So we don't need this t value, we need what? The p values. The tolerance there, you know how to, tolerance is used to check what? Used to check for multicollinearity. So when interpret maybe for checking which variables are significant, you can say, like for age, assuming that we are using 0.5 as our alpha, you can say that the alpha for the p-value for age is greater than what? Alpha, which indicate that it is not significant, and means that there is no relationship between what? Selling price of the house and what? And the age. And you can see, because you don't have to repeat a lot of things. And you can say, this is also confirmed by what? This is also confirmed by its confidence interval. Why are you saying it's confirmed by its confidence interval? Because from the confidence interval, 0 is included. You see? You don't have to interpret the p-values and again remove the confidence intervals. Whenever you're interpreting the p-value for size, you can also bring in the confidence interval for that size, for the betas. Provided you are using the same alpha. The last one now is what? Is the residual plots. Residual plots, this one, Mr. Chavala taught you how to interpret them. The first one, the first residual plot, residual versus predicted value of y. This first one is about the constant variance. This is about the constant variance, guys. Whenever you want to talk about the constant variance, you will use the first plot. When you want to talk about normality, linearity, you use this linearity. You can use the residual plot, the QQ plot, this one. You have done this part with Mr. Chavalala. This one, it was there. The histogram was there from the what? From the test. Remember, you'll be also using the internet to help you to interpret the results. Normality, you will use what? You will use this the histogram. What is the other thing to be checked? Check if you are not having outliers. Yes, the plot. R student versus predicted values. Now the residuals are standardized here. So if you want to check for outliers, anything which is outside 3 standard deviation is an outlier. How do you check if observations are influential? You use the what? The leverage procedure. Here is the leverage procedure. We'll see if it's not possible to also to give you the what? The leverage values. So you can only do some calculations provided you want to check for what? Provided you want to check for influential observations using leverage procedure. That's the only part where you can do some calculations. Otherwise, don't come up with your own calculations. Interpret, you'll be asked to interpret the given output. So please, guys, you are in a situation, collect as more marks as possible. Collect as more marks as possible. Remember, your assignment carries 15%, target around 14, 15, or target around 13%. Because if you have 13% from the assignment or 12% from the assignment, it's something. So please, you have powers to do it, to change the current situation. So if you don't know how to interpret a plot, don't just answer these questions for the sake of answering. You have the internet to help you guys. Again, we have another 2 plots here. Residuals versus size, residuals versus age. Again, these 2 plots, they are used to what? To check for the constant variance. So I want to add something again on the what? On the output part. The reason why we have to cover this is because in the afternoon we heard that you are writing, guys. We heard that you are writing a test at 2. So it won't be fair for us to have a class while you are writing, because some of you will be moving from off camp to campus. So we just want to explain these things so that it will help you to answer the assignment. We know, sorry if I'm rushing, but it's very, very important. I cannot say, since because you have the internet, go and figure out from the internet. So let's say we want to use the selection method. Let's say we want to bring in what? Selection method. You know those selection method, which is forward elimination method. Let me use, which one can I use? Forward. Let me use forward elimination method. Forward elimination method, and leg fit. I'm not sure. I will correct. Will correct me. I know this is not reading. The system is not reading that. Let me check what the system managed to give me this time. Okay. Now, as I've indicated, I said it's also possible to test for the lack of fit. I said it's also possible to test for the lack of fit. Now I ran the results now using forward selection method. What happened here? From forward elimination method, you know that you are having how many? Two independent variables. The introduction is still the same, but now there's an additional thing that we must add now, that for the given output, selection forward selection method is used or was applied to run the result. Must be specific that if you can check the first one, I didn't talk about selection method because it was not used. But for this output, we must indicate that the result were selection method that was used is forward elimination method. Must be specific. And again, you must indicate what the alpha used to enter or to remove. Um, how will you know that one which alpha was used to enter or to remove? Usually from the output, that information will be specified. Let me check it. Let me check it here. But as we said last time, we agreed that the default one is 0.1. I think for forward, the default one is 0.1. Can I ask you a question? Remember, there was a day where I spoke about select alpha for entry and alpha for removal. I want to ask you this question. Do we need significant level for removal when using forward elimination method? Do we need alpha for removal when using the selection method, when using forward elimination method?
No,
No. Why, my brother?
because we are not removing anything.
Yes, it's true. Remember, what's the definition of forward elimination method? Forward elimination method, whenever the variable is entered, cannot be what? Cannot be removed. We're stuck with that variable. So it means we need the requirement to do what? To enter. But we don't need the requirement to remove when dealing with forward elimination method. Let's go to backward elimination method. Which requirements do you need? Do you need the requirement to enter the model, or do you need the requirements to leave the model? Backward elimination method. Which requirement do we need? Do we need the requirements to enter the model, or do we need the requirements to leave the model, or we need both?
To leave them.
Sorry?
To remove.
My sister? We need the one to remove. Why? Because the first thing that was done under forward backward elimination method, the variables are entered. It doesn't matter if it's qualifying or not. So whenever you're applying backward elimination method, you need the significant level to do what? To leave what? Or to stay in the model. You need the significant level to stay in the model. You don't need the significant level to enter the model when using backward elimination method. But when you use forward elimination method, we need significant level to enter. We don't need significant level to stay, because the system won't help you to do what? To remove the value, the variable. The last one is stepwise. Do we need what do we need for stepwise? Do we need the alpha to enter and the alpha to remove? Or which one do we need there? Stepwise?
Both.
Do we need one of them, or do we need both?
We need both.
We need both, because it's possible that the stepwise and forward, they're similar. We need both. Why? Because it's possible under stepwise that the variable can be entered and can be removed. You see? So those are some of the things that we need to know. So you must understand this significant level for entry, significant level for removal. And you must understand why you are saying we need it. Isn't it, leaders? You said we need only significant, for backward elimination method, you said we need significant level to do what? To stay, because you said because of what? Because the final module will, or we should only have what? Significant variables. So we only need it for what? For removal. The one for entry, there are no requirements needed, because the first module to you enter all the independent variables. But when coming to forward elimination method, you only need the significant level to enter, because whenever the variable is entered, you are stuck with it. So you don't need the significant level for what? To stay in the model. The last one, stepwise, you need both. You must know the reason why. So as I was indicating, I explained the order of interpreting an output. So this procedure, I spoke about the lack of fit. It's possible to be given an output with a lack of fit. So with this one, if we check, we failed to do what? Why are we having dots here? It means from the data set that we were having, it's not possible to test for lack of fit, because we don't have what? Repeated observations. Remember, it means here you need to understand the definition of what? The definition of lack of fit. Why is it blank there? It means we didn't have what? We didn't have repeated observations. Yes, my brother?
So, sir, how do you test for lack of fit? What did you write there?
Remember, is it always the case that we should test for lack of fit? Start from there. Is it always possible to test for lack of fit?
No.
Why? When is it necessary to test for lack of fit? Remember, lack of fit goes with, may find that we have what? A value of y with having different values in it of x. Remember, here you must first understand the definition. When is it necessary to do the lack of fit, to perform lack of fit? You know, remember there's a part where you say you add some values. Why are you doing that? You must know the what? The background. Why are you testing for lack of fit? So reason why we're having dots here, it means we didn't have, our definition is not covered. So for this problem, we don't have repeated observations, which will need us to do what? Lack of fit. So it just indicate that nothing was reported because of 1, 2, 3. Based on the definition of lack of fit, it's not possible to perform lack of fit there. And then what else did I bring in? I forgot. Let me check. I noticed that time is no longer on my side. I think I asked for two things, or forward and lack of fit. Yes. Yes, my brother.
So regarding the test of lack of fit, so
Yes.
we consider the pure error, ne?
Yes. For this
So
one,
there
like the
they
one,
say
the
the
example
pure
that I
error is
just,
zero. The pure error is zero as in the results, if I'm not mistaken.
let me check. Yes, that's what I'm saying, Mr. It's manga, right?
Yes.
Yes, as I'm saying, we must first understand what is happening now. We must first understand the definition of lack of fit. It's not always the case that we should perform lack of fit. Understand that part. It's not always the case that we have to perform. There are some data sets which is not possible to perform leg of fit because of what? The definition of leg of fit. Let's understand the definition of leg of fit first. I think Mr. Wala shared that note with the note with you. And again, you remember about the DW. When can you use the what? The DW test. Remember, you see, the DW test is the Ben-Westin test. You know when to apply what? You know when to apply the Ben-Westin test. What are you expecting? So, what we're simply doing, guys, is everything that we have done in class. Let me remove this one. Everything that we managed to do them in class, but now we're doing them what? In a practical way. That is why we've been saying that don't always target what? The calculations. Because if in the afternoon I try to give you the output and your target was what? Was calculations. It means you won't write anything. Because if you can check here, most of the things that you need is to what? Is to interpret. Is to interpret. I wanted to check that leg of fit results. If it's given here. You see here it is, guys. Do you remember this part? Can you see this part? The logo, the Ben-Westin D with Mr. Chavalala. You know that you must use this is DW test. They calculated the DW. You go to the table, the DW table. You check for that lower limit and the upper limit, and you know how to make those decisions. So, but for the test, don't worry about this. But for the assignment, you must be able to do what? To test for the Ben-Westin. And you must know when is it necessary to do what? To test for the Ben-Westin. Provided we're given what? A time series data set. Why? Which assumption are we checking here? We're checking the assumption of independence to check if the if the errors are what? Are independent. You use what? The DW test. So based on my whatever I just explained, I know I was rushing, guys. Sorry for that. Try, guys, to collect as more marks as possible. If you don't know how to interpret, please, you have internet, you have the books. These things, they must help you to do what? To change the situation that we're in, because we're in a serious situation, guys, which need our focus. The situation we're the ones who can change whatever we're situation we're in. Please, any question? So we're still going to do the practicals. So we'll agree how will we do them, but you guys, you must be in the lab. We're not sure if they will allow us to meet in the lab, but if we fail, you make sure wherever you are, you run the results. Whenever I'm running, you also run from their side. When you don't understand, you say, stop, I don't understand this part. I'm not getting the same results as you are getting. So we'll share the data set that will be used to run. We can use to run. We'll use Excel. We can start by using Excel to run some of the things. So please, next week, I have to keep my promise that we'll use statistical softwares to run results. You must do it also from your side, not the way I'm doing it now. I'm just doing this so that you'll be able to do what? To answer your assignment. Any question, please? Any question, please? If you check, guys, I hope the class rep is here. The time we were giving the scope were 120. But now, because we're teaching, we are only 74. I hope you noticed that. So, yes, I will run to answer my Nyama question. We'll run the results for you, leadership. I will run them for you. I will just give you the output as I've indicated. I can give you 10 outputs, you choose one. You choose one. So we'll share the outputs together with what? Together with the data sets, so that you can get what? The opening statement. So please, what we're expecting from you is just to write a report. Report what you are having there. Make sure that you write the right things for the sake of marks. Write the right things, guys. I thank you. Enjoy.